welcome to another episode of How to Take Over the World with Basic Physics Concepts. Today's concept will be point charges. And I'll try to slow it down this week since last week I must have done something wrong. Or maybe you guys are just really stupid because nobody's taken over the world yet. And I'm starting to wonder if they ever will. So, the first thing that we need to know is that electric field and electric force are related because electric force is caused by electric field. So, an electric field causes electric force. That's basically it. Now, the superposition principle, and it relates to electric field and electric force because if there is one or more charge present, then the total electric field at any point is equal to the vector sum of the separate electric fields. So, say we have a doomsday weapon that involves electric fields. So, say we use two of them. Two that are both negative. Then they would basically double the power. But if you say you had a positive field and a negative field, then they would somewhat cancel each other out to the point of non-existence if you got them close enough to the same charge, which would be worthless and not worth having and just worthless. Now, if an electron is passing through a uniform electric field directed downward, what will happen to the trajectory of the electron? So, it will be repelled downward because the field is negative, and so is the electron. So, back to the old concepts, that is opposites repel. Now, opposites attract, like repel. So if the field's negative and the charge is negative, then they're going to repel. So say you have a force field, and someone is shooting you with an electric charge that is negative, which your force field is also negative. That charge won't be able to hurt you. It'll bounce back from the force field and hopefully hit whoever it is that's shooting you, which is probably Bob since we still don't like him. Let's just say it hits Bob back. It would hurt him. So it wouldn't hurt us, it'd hurt him, win-win. So, are charged particles affected by a magnetic field? I'm going to say yes. And we can test this because they will start spinning, which is pretty cool. So if we need to test if a particle is affected by our field, then we can just apply the field, and if the charged particles begin to spin, then we will know they're affected. So, the fundamental charges. This seems like the biggest thing and the most important thing there is on here, is because they're fundamentals, like atoms, make up everything. They're the basic, cannot be quantized. It is as small as it gets, folks. So, 1.6 times 10 to the negative 19th is the charge for a proton. A proton is the positive piece. The electron is negative 1.6 times 10 to the negative 19th, which is the charge of an electron. So, basically, they're both really small numbers. They're small pieces, so they have to be small numbers, but they're still very small numbers. Electric potential energy. This is important because if we can harness this, then we could make a lot more happen than usual. So the potential energy that results from a conservative Coulomb force is associated with the configuration of a particular set of point charges within a defined system. So, potential energy is something that could happen, but needs another force to actually make it happen. So, okay, that's the same idea as putting a big boulder on top of a hill on the edge, but it doesn't move. It has a lot of potential energy because, depending on the size of the boulder, a boulder would have to be pretty big to be classified as a boulder. So, that means that it would have higher kinetic energy, higher potential kinetic energy. So, it would take less force to set that off. So it's, in effect, a ticking time bomb waiting for something to set it off. The same thing with potential electric energy. Say we have batteries. Batteries have the potential to release their electric energy. Could be all at once, could be slowly through like our TV remote or a mouse. But it requires a force or another object to do that. Say we were to create some kind of weapon that would, I don't know, release all the charge at once. Be a lot of electricity. And if then we could collect it, then I think we might actually take over the world this week. But the week is young, and again, I have little hope for you guys. And define potential difference and how it relates to point charge. Well, potential difference is the difference between two different point charges, which it kind of implied, but I guess I needed to show you guys since you guys are a little kind of slow. I mean, it happens to the best of us, but still, you guys are slow. So, how we could take over the world with these concepts? Let me see here. Well, using potential energy, we could create a weapon that harnesses all the electricity at once and then fires concentrated bursts of this energy, which would basically destroy whatever you shoot it with. So, say we're just vaporizing something. That could be fun. Use it for that. And then another electric force field idea is that we could collect all the energy that we have released with the potential energy concept. Just collect it all into one field. They couldn't touch us. It'd be pretty awesome. So, good luck, guys. Try to take over the world. You'll probably fail, but you know what? If you actually manage to succeed, then give me some credit.